So the first time that I started gathering content for this talk was around 12 years ago. And I was in the middle of very strong professional and personal transformations. We were a small Java shop with 5 developers, and in a few months we were 150, and in a couple of years we were 250. So we started thinking, hey, what worked for us before is definitely not working anymore. And the funny thing was that we had really, really good developers, and for some reason, the outcome of those developers was not as good as before. And when I was putting together my notes, it was funny to see how many things fundamentally changed from that 2012 into today, because technology is fundamentally different. But there are some things that are still the same. For some reason, this line of work, this profession, this life of software tends to attract people that are really passionate about it, that really care about the outcome of our code. We like to see elegance. We like to see beauty in what we do. In a way, we're like the blacksmiths of the digital era. In a way, we see what we do as a craft, and every day we want to become better. Very similar to a blacksmith when she is finishing a sword and steps back and watches what she just did with some sort of amusement, some sense of pride, but also with some sense of critical eye. I could have done this better. Isn't that the same what we do in our pull requests? So a lot of what we do is around coding. But something started to emerge in those transformations that I had. Coding, it was not the solution for everything. Good code was not the solution for everything. There was a guy, Joel Spolsky, that had a really good blog at the time, and he had the idea that if you have the best environment, you're going to attract the best developers, and if you have the best developers, you're going to have the best software. But it was clear to me that that was not the case. So we started wondering around, hey, how can we make this better? At the same time, a really close friend of mine approached me and asked me a question that was kept in my mind for a while. And he said, hey, Luis, by the way, my name is Luis Fernandez. I'm from a very beautiful small country in Central America, Guatemala. I live in Houston, and I work for an amazing company, VML. So he was telling me, hey, Luis, I'm thinking about switching careers. I'm an industrial engineer, and I would like to learn how to code. Is it easy to learn to code? Is code easy? My first reaction was, go ahead. There are so many books, there are so many courses, there are so many YouTube videos. At the time, the YouTube videos were constrained to 10 minutes. Go ahead. Coding is really easy. Then something in the back of my head said, oh, if it's that easy, why you spend those long nights fixing your bugs? Why do you have all those fights with yourself when you don't understand something, or when you want to implement something in a different way? So I started looking around on, hey, in a way, coding is easy, because you can learn how to code in a couple of weeks, especially if you have some math background. But to really learn how to code takes a lifetime if you ever get there. And my analogy for him was like, hey, yeah, coding is easy. but it's like playing chess. I can teach you how to play chess in a day, but from that into becoming a grandmaster, it's a lifetime journey. I mean, because coding is not necessarily easy. Starting on that path, I landed on some terms, and I truly believe sometimes that being bilingual helps your brain to see things from different angles. And one of the words that I landed at was complicated. Writing software is definitely complicated. And I started looking out for definitions of complicated. And solving a Rubik's Cube can be quite complicated. Setting up that IKEA furniture can be complicated. But there's something about it. You know that you'll be able to solve it. You know that there's an algorithm that's going to take you there. Executing that algorithm can be really complicated, but you know you'll get there. You can solve towers of Hanoi. You know they can be solved, but if you have 64 towers, you know it cannot be solved. You know that there's an algorithm. It's extremely complicated. It's infinitely complicated, but there's a way to do it. On the other hand, I landed into another concept, which is complex. Something that is complex can have an algorithm, can be seen as following a recipe, but it's not necessarily solvable. Trying to figure out patterns of weather, that's very complex. That is very complex. You know you can try, you know you can model, but you know that you will never have enough variables to do it. So in Spanish, we have a word for complex and we have a word for complicated. In English, if you go and search for the opposite of complex, it's going to be simple. But the opposite of complicated is going to be simple as well. I actually learned that there's an uncomplicated, but most people would just simple. So let me introduce a word in Spanish to all of you, sencillo. In Spanish, we have this word sencillo, which is the opposite of complex, of complicated. Solving a 2x2 Rubik's Cube is very sencillo, but solving a 4x4 is very complicated. So we have these two elements, and we have these two, let's call them dimensions. And I was like, okay, definitely software can be complicated, and definitely software can be complex. But there are different ways of approaching this. If I ask you to go to any of those coding challenges out there, most of them are going to be really complicated. But you know that there's going to be an answer. If I ask you, hey, set up that e-commerce system, you know the recipe, but actually you don't know if you're going to get there. And my first impression is like, yeah, sure, I can do it right. Oh, really? How many failed e-commerce implementations have you seen? And there's a path of complexity. It's not the same creating an e-commerce for a small shop on a software as a service that has, 100 SKUs than creating a software solution for an e-commerce platform that has a few million SKUs, 35 different markets, 25 different currencies, etc., etc. There are levels of complexity. So I was drawn into thinking that software tends to be more complex than complicated. But something in my heart kept telling me, hey, most of the issues that I see in my day-to-day are not because we are not finding the algorithm. It's not necessarily about the execution. It's about something else. It's about a little bit more on the complexity of the beast. So, yeah, I decided that delivering software is both complicated and complex, but it's more complex than complicated. and I will show you later why. It's very complex. It's very complex. And I had to come back to my friend and tell him, yeah, it's you have to really like to build software. You have to really get in love with it, because it's going to be a pain in the for a long time. But you'll enjoy it. It's a weird thing, but we enjoy it. So while looking at about these concepts, I landed on a couple of layers of complexity that were proposed by McDonald, which was the author of Code Complete, a book that if you like coding, you should definitely read at some point in your life. He started speaking about something that he mentions as essential complexity. Essential complexity is a complexity that is very inherent to what you're trying to solve. The essential complexity of the small e-commerce shop is way lower than the essential complexity of the large e-commerce. You cannot get rid of it. It's complex by its nature. It's what you have to solve. It's the problem that you're trying to figure out. On the other side, you have accidental complexity. Accidental complexity is everything else you add to it. So for example, if you talk about accidental complexity in that e-commerce, you would say, hey, I'm going to do it in a monolith. I'm going to do it as a software as a service. That's way less complicated than deciding, hey, you know what? I'm going to do it with microservices. I'm going to do it headless. I'm going to do it, etc., etc. Sometimes I prefer that complexity in sake of something else. I say, hey, I'm going to go with this complex path because I want the scalability, or I want the performance, but I'm making my system more complex. And as designers, our job is going to be finding out ways to lower that accidental complexities. Still trying to figure it out, on design thinking, I came across to the concept of mysteries and puzzles. Very similar to what we had before in complexity and complicatedness. Mysteries are those things that I don't know if I'll be able to solve. Is that detective that knows that a crime has happened, but you don't know if you're going to find the culprit. You know that there's going to be a recipe. You know that there's going to be, but you know that very likely in some occasions you won't find it. Becoming rich is a mystery. Why? Because everybody tells you the recipe, but there are not that many riches. Being happy, it's a mystery. Puzzles, on the other side, are, well, puzzles. You know that once you have the time and the capabilities put in place, you are going to be able to solve them. The crypting 256 key, it's solvable. If you have enough time and enough power.
I just had a question.
Sure.
He's using these two words, complicated versus complex, and you compared it to mysteries and puzzles.
I'm going right there.
So is it mysteries? Isn't it just you haven't defined the question well enough?
In what term?
I mean, that's the only difference I see between mysteries and puzzles.
Let me get there. And you tell me if I answered your question. So, why this is important? Because each one of them require a different mindset. For puzzles, we need expertise. Expertise is what I can tell my friend, hey, go to that Java boot, go to that course, take that bootcamp. You will learn how to code out of those places. Expertise is what you can get out of a book by yourself. Experience, on the other side, is what some people call tacit knowledge. Tacit knowledge is anything that cannot be learned by reading a book. Learning how to swim requires experience. Learning how to ride a bike requires experience. Learning how to be a lead developer requires experience. You cannot be a software architect if you have not been a lead developer or if you have not been a developer. There's no way somebody can teach you that. But experience has to be deliberate. If your experience focuses on the same thing, you might have the same expertise over and over again. Not everybody gets better at driving as time goes by. Why? Because they have the initial expertise and then they are not adding more experience. So to your point, when you put all of these concepts in the same page, this side of the house, the right-hand side, is going to be where most of the code-related stuff is going to happen. Code tends to be sencillo, simple, apostle, and expertise. I am not saying that code cannot be stupidly complicated or incredibly complex, or sometimes it's a mystery. But most of the time, in the work that we tend to do, it's going to be around here. Most of the projects will not fail because the coding was so complicated. Most of the projects are going to fail because something else, because the complexity, because the mystery, because the requirement, all that good stuff. So part of the complexity lies in the context. And the context of software is the concept that when I start writing software, this is almost the end of the line. There has been so many other considerations and so many decisions that have been already taken that coding is at the end. And sometimes, if those considerations are not well structured, there's no way the best code on earth is going to save that project or that software from failing. And part of the context of code, it's the organization in which codes are born. Not all code is born the same. When we assembled that company, we got acquired. And I have been very fortunate of working with a decently large set of people for over 15 years. And in those 15 years, we have been acquired and reacquired and merged 5 times. And those same developers delivered different software solutions of different quality. They were the same guys, they were the same experts, but the outcomes were fundamentally different. And that's when, a few years later, I started to think more about this. There's something about the organization. The organization has something to say about the code that can be created. So if you design a software system, that system can result, that design can result in different systems. This is pretty obvious. I mean, I have an architecture of anything, and I ask a team to deliver that something, and I ask another team to deliver that something, the outcome is going to be fundamentally different. Just by saying, this is going to, if I ask a PHP team or a JavaScript team to solve or to implement the same thing, the outcome is going to be fundamentally different. Viewing it from a different perspective, different organization will deliver different software. And again, sounds pretty obvious, but in our experience, we ignore that obvious thing. And we tend to assume that the important thing is to write good code. An example of this can be a fast food restaurant. In a fast food restaurant, you have cashiers, you have a cook, and you have some other personnel that have been trained very explicitly to cook in a certain way, to interact with clients in a very specific way. They have taken the complexity of the system of creating food and turning it into something very complicated. What's the magic about that approach? If one cook is sick today and he doesn't go to work, you can call the central and ask for another cook that is going to have the same knowledge, that is going to have the same training, and you just replace it, and the restaurant is going to be working as yesterday. In a worst case scenario, if everybody in this restaurant quits, and central management hears that, they can send a new pack of people at the restaurant, and in 2 hours, that restaurant is going to be working as before. Why? Because they have taken the complexity, and they have created a system of delivering food this way. On the other side, if you go to a Michelin restaurant, it's quite of the opposite. Michelin restaurants tend to rely on their master chef. If the master chef is gone, in a way the restaurant is gone. And the master chef has a team of people which have been working together for a long time, and they deliver, in many cases, dishes that are different night after night. So that is way more complex and sometimes can be more complicated. Two methods of delivering food that are fundamentally different because of the organization. So what I end up understanding is that really good developers can, depending on the organization, make really bad systems. And very average developers or entry-level developers can create really nice software if the organization is set up in a way that handles that. So we tried a couple of different things at the time, and we landed into this concept. How we, as a software production entity, create software is what makes us different. Clients come to us because of the way we deliver software. And there are different ways of delivering software, and there are a lot of philosophies, and there are a lot of, you might go to this shop if you want something quick and dirty, or you might go to this other shop if you want something of a higher quality, of more experience and expertise, etc., etc. How you write software, it's at the core of your offering as a software company, not your code. Again, sounds obvious, but in most cases, it's not. So something that that matters also a lot in this whole thing is the ecosystem of a developer. An organization in which your developer reports to another developer is going to produce code that is different than the organization in which the developer reports to a product owner, for example. Here, very likely the code is going to be neater, it's going to be better code, because the developer understands that he'll be evaluated based on the quality of the code. Here, on the other side, likely the code is not going to be as neat, because she is going to be measured against how quickly the code is delivered, or how well is she interacting with the client. So that ecosystem of the dev, hey, how are you in the midst of complexity and making things complicated in letting the developer use their own IDE or their own set of tools, or on the other hand, you need some standards or some unanimous way of working, so we understand what somebody else is doing. But that ecosystem of the developer, it's very important. So on those changes, we decided, hey, something has to change. We're not delivering the best code anymore, or maybe the code is good, but the software is not good. So we need to change something. Please go ahead. So we started thinking, and we tried to apply the advice of this gentleman who have read this quote before. So Einstein said that insanity is doing the same thing over and over and expecting different results. But that is not true. He didn't say that. And when you go online, and to me it's very mind-blowing to see how many resources you see. Hey, I said this, I've seen posters, and I've seen, but he never said anything like, there's no way to see this coming from Einstein in any of his talks, in any of his writings. And the same happens with this gentleman. Who have heard about Conway's and Conway's law? Okay, not that many. And I hope that after today, all of you will read about his work. We're going to be reading some of his work today. If you go online and search for Conway law, there are so many things about Conway that are like the Einstein quote. There are so many attributions of the Conway's law and saying, hey, this is why we should be changing this or that. And Conway never said that. I had a teacher at my university that always told me, when you want something to be better understood, go to the source. I like philosophy a lot, and he would say, hey, go to the source, go to the source. Read, if you like Plato, read Plato. If you like Aristotle, well, we don't know if he existed, by the way. So go to the source. And in this case, the source is very simple, because Conway's law stems from a 4-page document. I'll give you the link later, that I think everybody that deals with software has to read at least once, because it sparks really good ideas. This was written in 1968, and as for today, a lot of his writings are still relevant, and as for today, we have not heard what he had to say. So, what Conway say? And I'm going to take some extracts from his text. Can you read? Okay. Here Conway says that his paper goes around how an organization designs software and how that design software reflects in a way the organization. I'm not going to be talking about Conway's law today. There's a lot of really good material out there. I will share the links later. But I want to focus on his paper and what he wrote. So first thing that he says is that many of the design choices stem from personal decisions. And that's something that we very commonly forget. The architect or the designer of any software, or the organization that is designing any software, has a vested interest into that thing that they are creating. And that might be something very simple. Hey, I want to learn this framework, or I want to specialize in this other language, or I want to be partners with this provider, or etc., etc. Those decisions have consequences. And ignoring the personal decision of the designer also has consequences. Because again, this person wants a promotion, wants to get a rise. Conway said this, again, long time ago, and I still see a lot of organizations, I would say most of organizations, that simply ignored this fact. When you start organizing a design team, there are many things that have been already defined, whether you like it or not. And what I love about the way Conway put it is the fact that if you make it explicit, you're going to be able to play with that. If you don't, you won't. When you choose a framework, there are some decisions that have been already taken for you, especially if it's something very opinionated. If you're going to be outsourcing this, there are some decisions that have been already taken in the way that software is going to be built. And once you have that set in place, there comes in another complex problem, which is a coordination problem. You have that system, you have the idea of the system, or you have whatever you want to build on that system, And now in many companies, it'll be resourcing, or it's going to be staffing, or it's going to be something else. But there's going to be a coordination problem. And that coordination problem is a problem because of communication. It's not, when you have 2 teams, and when you have 5 teams, the complexity is going to be way bigger when you have 5 teams. And that complexity will impact the way the software is built. What else he said? And I love this paragraph because he actually uses a quote. Following this proof, we have demonstrated that there's a close relationship between the structure of a system and the structure of a system that designs. This is essentially the stem of Conway's law. I'm going to show it in a couple of slides. But what he's saying is, like, if you have 2 teams, your system is going to be composed of at least 2 layers of something. If you have 5 teams, guess what? Your system is going to have 5 different layers. If you have just 1 team, very likely you're going to create a monolith. If you have a team that is front end, and a team that is back end, and a team that is database, guess what? Your system is going to have a front end, a database, and a back end. But if you see it from the detective point of view, when you check on a system, you can infer this was a system that was created this way. I like the proof because the way he wrote his article was very humble. He never pretended to come up with a law. And that's something that we always have to bear in mind. In software, there are really, really just a few laws. There are so many laws out there that are more like guidelines. And even you can argue that Conway's law does not apply everywhere. So when you read about a law, and there's a collection of laws in software, go to the stem. Because very likely, the guy that proposed that idea was not looking to create a law, and somebody else in the middle decided that it was a law. Another concept, your first stab at the design is not going to be likely the better one. He was, at the time, kind of inferring how to work iteratively, how systems should be built in a quote-unquote agile way. Another key one, and remember, this is 1968. He said, hey, the way we're measuring software cannot be the same way we are accounting for the world that we have known to these days. We cannot measure developers by the hour. We cannot measure an architect by the hour. Why? Because that's an account system that works really well, as he said, for peeling potatoes and erecting brick walls. That's really good measurement for that, but it's not a good measurement for software. And guess what? Today, a big chunk of organizations are going to measure developers by the hour, are going to clients, developers by the hour. 60 years ago, and still we do it. Okay. For those who work on organizations that provide systems, Conway say, hey, possibly one of the biggest sources of poorly designed system is the availability of a team to implement that system. And that, again, happens quite a lot. What do we do with these people? I have a front-end developer, or I have a pool of front-end developer, and I have a back-end job. So I'm going to say, oh, they're going to be full-stack developers. And I'm going to assign them into something that they cannot do, and still I'm going to call it so. So in his paper, 4.5 pages were about these observations. His conclusions, his law, and this, if you go online and search for Conway's law, this is what you will find. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. You are constrained to build software the way you are organized. Out of the pool of possible solutions, you are going to land in the solution that reflects how you are organized. What else he said? A criterion for structuring a design organization should come especially focused on communication, how the organization communicates. And it's not only verbal communication. We communicate through code. We communicate these days through CI/CD. We communicate through Jira, Confluence, whatever. There are channels of communication. We need a concept that focuses on change. We need a concept that allows the organization to change as software changes. Why? Because our first architectural decision is almost never going to be the best. And that's something that he saw at the time. And still, I have found just a few organizations that actually are flexible enough to change throughout the life of projects in terms of the organization, in terms on how to reward the manager. Who is going to be getting a rise if something goes well? Who is going to get let go if something goes wrong? What are the incentives that we have in terms of organization? So, finally, he says, hey, we need a new philosophy. What we have is not enough. Why this is relevant? Why thinking about software that has complexity, that it's complicated, that can be a mystery, but also can be a puzzle, and a software that is born from an organization is part of the complexity of software? Why this is relevant for us that we deal with code? We don't really care about the organization. But it's relevant because of one thing. Do you think HR is laying out the grounds of your software architecture? I'm tempted to say that at least in half of the people sitting right here, HR is, or upper management is. When HR or somebody that is not in the software arena decides how the org chart is going to be, they are taking software design decisions. And when we were building that company a while back, one of the biggest problems that we had was actually finding somebody in HR that would understand how software works. Why? Because they would come with like traditional HR foundations and come up with organizations that will collapse in the software world. So, talking about this, there's the concept of your org chart debt. We all deal with technical debt, and we know what it is. We're going to take some shortcuts here because we don't have time, because it's going to be cheaper, whatever, and we'll fix it later. In the way you are organized, it's the same. And here's also another thought. Coming up with an org chart, it's a very complicated thing. It's something that it requires expertise, it requires reading the books, etc. Creating a culture, it's a very complex thing. And there is no way you can do it by prescription. Culture has to grow. Culture has to come from the team. Culture has to be part of the organization. And why it's important to have a strong culture? Because culture can amend some of the errors that our org chart has. Why? Because you are going to open new paths of communications that are going to make your life easier. Then frameworks and platforms. The same way you choosing the organization constrains you to a set of solutions, the frameworks and platforms that you choose also are going to constrain your solution. This is a little bit more obvious, and when you go with a headless CMS, guess what? Your solution is going to be a headless solution. Here, it's very obvious. but in the way we deal with organization, it is not. There's a really nice book called Emergence from a guy called Johnson. And one of the interesting or fascinating things about that book is that he talks a lot about ants and ant colonies. Ant colonies are very complex and very complicated structures. And there are patterns that can be seen in any ant colony. For example, all of them have a cemetery. For example, all of them have a cemetery that is as far as possible from nursery. For example, all of them have a cemetery and a nursery that are as far as possible from the food. And as long as the complexities start growing, there is going to be some solidification of this reality. Ants, in a way, they follow Conway. Our organizations, even if we don't see it, especially when they grow, they follow Conway. After Conway, we have a lot of spin-offs or a lot of ideas that came out of his concepts. One, it's Team Topologies. This is a book from Skeleton and Manuel Pais, really good read. And here he goes with a concept of cognitive load. The same way a developer can deal with as much of information, as a team, we can deal as much of information depending on your communication paths. So creating more teams has to be a function on how we're communicating and the team cognitive load. Focus on flow, not on structure. Be fluid. It's very agile way of doing things. And one that we typically forget is keep teams together. DeMarco and all the fundamental software books mentioned at the time that one of the outputs of a software effort should be the team. And I can tell you, keeping the same team working together as a team over years has no comparison in the way how fast you're going to be delivering, how well you're going to be delivering. But quite very often what happens, if you're not in a product organization, it's like those teams are going to be disassembled at the end of the project, and that's always a lane. On Team Topologies, you also have some interesting concepts that I don't think apply to every organization, but I think are really good sparks to think about how you set up something. So you have the communication paths, you have the interfaces, you have how people should be communicating, because communicating is not broadcasting. I don't want anybody losing time reading everything. Communicating, I need to read or to interact just with the things that I need to use in the code that I'm going to be using today. They also propose 14 types and 3 interaction modes. Why, again, this is relevant? Because it gives you thinking points. And I believe that this will not apply on most organizations, but thinking about it applies to all organizations. There's another spin-off of Conway, and that's the Inverse Conway Maneuver, or Reverse Conway Maneuver. What's the idea behind this? If you know that your architecture is going to be a reflection of your team, why not we create the teams so they reflect that architecture? And I think that's really handy, and I think that's really powerful, but there are 2 caveats. One is that Conway mentioned that likely your first architecture is not going to be the same, so bear that in mind. Second, you have to have a lot of power to change, to be able to change that organization. Think also that your clients are part of the system. It's not only about how we are going to be bringing to life a new solution, it's how we as clients and software providing organizations are going to be creating that system. A good example that I experienced 10 years ago was with an airline. They are still the largest airline in Latin America, and we were providing a new launch for their website and their app back in the day. In 2015, it was really a new thing to check in online, especially when you would be doing international traveling. And there were some law complications here and there. And the apps didn't have like the check-in capabilities that we have today. This airline decided to do something very different and, in my opinion, very successful. They decided, hey, you know what? We're not going to be organizing ourselves in the typical way. We have finance and we have IT and we are going to organize ourselves following the journeys of our travelers. So what they did is they created a team that was in charge of everything that was not at the airport experience or inside the airplane experience. So they had a team that was in charge of SEO, of coming up with a web page, of pricing, of how you create your search modes or your search capabilities. And each one of them has the independence to be able to choose whatever system they had. They were not constrained saying, hey, everybody's going to be using the same CMS. Everybody's going to be using the same suppliers. And they could negotiate to use the same one because it would be cheaper, but everybody was free to do whatever they want. So they had that team. Then they had another team which was focused entirely on the experience at the airport. Since the moment that I step in, how my interaction with the airline happens. How do they handle lines? How do they handle waiting times? How do they handle delays? How do they handle... And that team was in charge of thinking how technology can help that experience to be better. And there was a third team which was focused entirely on the experience inside of the plane. Once I step into the plane, how can I make my experience more pleasant? Out of that thinking, they realized that they didn't want to put a screen on each one of their planes, and was also really expensive. And they were the first airline that came with the idea of saying, hey, why don't we provide Wi-Fi on the airplane? So everybody brings their phone, and everybody brings a phone, even at those days, so we can stream something. And in my opinion, all that thinking came from organizing themselves in a Conway way. Why I think this is relevant for all of you. If you're a developer, if you're starting your journey, I think this is especially relevant because whatever you're going to be working will leave you an imprint on how you see life. Understanding that your organization takes into account how software is built, it's going to make your career very different. If you're a developer, if you're a lead developer, start having these conversations with your manager. Start having these conversations with HR. Sometimes you feel that something is off, but you don't know what it is. And in many cases, it's the way you are organized. And I can bet that at least half of the organizations here that have more than, 20, 50 developers, you're going to have a front-end team. You're going to have a back-end team. You're going to have a database team. You're going to have... If you're organized that way, know that you are imprinting an architectural base for your system. And if you are in a positions of changing this, test it out. It really, really works. And with that, I would like to thank you. I want to thank all the sponsors. I work for that little one, and it's an amazing company. And if you want to write amazing code, it's a good place to be. But BML, yeah. But to all of them, thank you. To the organizers, I have been amazed on how well this event is it's organized. So thank you to all of them. Here you have the scan for the feedback. If you like the conversation we had, please say so. If there's something to improve, also please say so. On that one, you have also all the materials, all the links of books, videos, articles that I use to build most of this conversation. Then there you will also have my contact. I would love to be connected with all of you. And later today, I'm going to be uploading the presentation. So, questions?
So if you work for an organization that's already more structured from the database team, software, engineer people, etc., have you seen any good patterns for testing a new team structure while not having the people above you getting afraid of it?
Yes. The biggest challenge or the biggest anti-pattern that I've seen, it's people are afraid. And it's like, hey, how this is going to change my salary, or how this is going to change. So a good pattern would be when you have somebody in a position of power that is willing to test that out, convince them. Have them read the Congress paper, because it's going to have a big impact.
I think as like a technical person, you're probably better off just going and finding that organization as opposed to trying to change it. I mean,
Yeah.
this is all great information.
Yeah.
But it wastes a lot of time spending years
Yeah.
trying to change it. From the bottom,
If you want to make your life easier, I would definitely say that's the path to go.
right?
Yeah.
What do you think of domain-driven design as a way you have domain-based teams? Is that a good way to get around the
I think DDD gets really along with what Conway said, because on DDD you start the design, you start from the design, and that design has to be as agnostic as possible from the rest of the implementation aspect of that design. So usually on DDD you will start with the business domain that you're trying to solve, and then you're going to land on the tech domain that you're going to use to solve the problem. But if that domain, when you land that it's fractured, your DDD is going to end up being fractured.
Well, that's what this team was, this domain was structured previously.
Yeah. Awesome. So thank you all. Enjoy the rest of KCDC. And yeah, thank you.
So what's your title? I'm a developer. Engineers and providing. But I mean, I still help for all of that. When I did it on 10 places.
Okay.
It's awesome. I'm gonna stay here forever because it's perfect. Like it's like that because it's.
Yeah, and I think it's a combination of factors, and that's where the complexity is very interesting, because
And I definitely like to give it to like an organization because I would like to hire you for like my underwriting trying to do it. I feel like I am, but just you're oversight and stuff. If I give you contact,
yeah. On my link, you have one for the material, and there is a link somewhere that says that you're gonna reach me out.
so just trying to.
I'm on the other side of it where like so I'm the senior for my team, and my manager gets one of them. We can do a lot of this experimentation. The problem is every other team inside the organization is unless we're the only ones that can experiment at this point. And a lot of what you said definitely fits into. I think you gave me the words on for those pieces because like it's a complex problem of getting the organization to change. 11 years. Yeah, I have had wins. I don't know that I've been successful. But yeah, see for our town.
And when you feel that, it's not because of the code that you're writing.
No,
it's
it's
because
not.
the
Actually, I'm
layers
not happy as when I'm writing the code.
And
And I'm
I actually do my job today, except if I'm meeting with the stakeholders and I'm making sure that they get the best product that they're going through, then yeah, that is a lot. So I really appreciate it. I'll be in contact. Thank you very much.
Awesome. Thank you for coming in.
A great talk.
Thank you.
Have you had a look much, I know like system design, really incentives and goals, like, I always tell people when they're looking at stuff, you see a lot of times it's like, you work with CTO versus CIO, and it's like cost center. So you'll see like these conflicts that come down from organizations, like this is our goal, this is our incentive, and it comes up a lot, and like, if you look at that lens, it helps you kind of deal with like, how to manage.
For example, I work right now in, I would say, that has a huge tech side of the house. And because of advertising, everything has become that big. So we have had a lot of discussion with how the advertising side of the house handle things and how we handle it. To an extent that we ended up becoming an organization inside of a bigger organization because the incentives that work for them, they were useless in the best case for us. Yeah, thank you. Luis.
I don't know if I really had any questions.
I'll be just let me take it out to the next
Oh,
video.
Sure.
You're up. Thank you. Thank you. Thank you. Yep. Now, I get to enjoy. Yeah.